Assalamualaikum warahmatullahi wabarakatuh. I am Sharifah Nurul Shakira binti Said Aziz and this is my group name.
I'm Siti Afika binti Ar-Azmi from Section 1.
I am Siti Narwalidatun binti Zulkifli. In this video, we will explain about electrostatic potential energy. In the capacitor, a source connected to a capacitor and expends energy in charging up the capacitor. If the capacitor plates are made of a good conductor with effectively zero resistance and the dielectric separating two plates has negligible conductivity, then no current can flow through the dielectric and no ohmic losses occur in the capacitor. So, energy end up getting stored in the dielectric medium and called as electrostatic potential energy. The amount of stored energy is related to charge, capacitance and voltage. Okay, now we will go to the definition. Electrostatic potential energy is a potential energy that measured in joule, where the results from conservative Coulomb force and associated with the configuration of a particular set of point charge within a defined system. What will happen when capacitor charging up? Okay, during a capacitor charging up, first the voltage across of capacitor will increase from 0 until at a certain value of voltage. Okay, next the value of charge will increase from 0 until a certain positive charge value occur to positive terminal of DC supply. Okay, last but not least, the charge at the negative conductor that connected to the negative terminal of DC supply will accumulating from 0 until a certain negative charge value. So, the formula of voltage was formed, which is voltage across the capacitor equal to charge over capacitance. Okay, that's all from me. Now we will move to the next presenter. Okay, thank you.
If we transfer a total charge Q between the conductor of an initially uncharged capacitor, the total amount of work performed by dWe equal to V dQ, where V we substitute from previous formula voltage across the capacitor, V equal to Q over C. So we get dWe equal to Q over C dQ. To remove D, we must put integration on both sides. So we get WE equal to integration 0 until Q over C dQ. So the final answer for the total amount of work, WE equal to 1 over 2 multiply Q square over C, and their unit is joule. By using formula capacitor C equal to Q over V, unit farad, where V is the final voltage, so we also can be expressed as WE equal to 1 over 2 CV square and unit joule. Then we substitute C and V, where C is epsilon A over D and V equal to ED, where epsilon is permittivity of dielectric, A is area of conductor, D is thickness the dielectric material, E is magnitude electric field. So we get WE equal to 1 over 2 epsilon E square AD, where AD is almost the volume of capacitor. So the final answer is WE equal to 1 over 2 epsilon E square lambda, where lambda is volume of capacitor and their unit is joule. If we consider the previous equation of energy, in terms of density value, so WE equal to WE over lambda. We substitute WE where WE is equal to 1 over 2 epsilon E squared lambda. So the final answer for electrostatic energy density WE equal to 1 over 2 epsilon E squared, and their unit is joule per meter cube.
Question. 2-point charge 4Q and Q are separated by 1 meter in air. At what point on the line joining the charge is the electric field intensity is 0? So here sketching. Let electric field intensity be 0 at any point P lying at a distance x meter from charge Q between the two charges on the lining joint. So A equal to B. 1 over 4 pi epsilon naught times Q over x squared equal to 1 over 4 pi epsilon naught multiplied by 4Q over 1 minus x squared. 1 over x squared equal to 4 over 1 minus x squared. To find the value of x, we should multiply all the equation with 1 minus x squared. So here we got 1 minus x squared over x squared equal to 4 1 minus x squared over 1 minus x squared. So we get 1 minus x over x squared equal to 4. So we solve the equation. We get x equal to 1 over 3 meter. So next question, calculate the electrostatic potential energy of the system of charge, taking the value of charge Q equal to 2 times 10 power of negative 7 coulomb. So here, electrostatic potential energy U equal to 1 over 4 pi epsilon naught 4Q times Q over R. So here is the constant value, which is 9 times 10 power of 9, 4, and we substitute Q with 2 times 10 power of negative 7. Divide by 1, which is the distance, 1 meter. So we get the answer 1.44 millijoule.